Hello everyone. I would like to talk about how to build a test for diverse fleet of platforms and how hard that could be. Few words about me. I'm Evgeniy Paltsev. I've been working on various pieces of system software for Arc, mostly based on open source projects like Linux kernel, Ubuntu, and others. But lately, I've become a maintainer of Arc architecture in Zephyr tools, and so spend most of my time making it better for Arc and others. We've seen a lot of interesting things, which we are going to talk about now. In case of Zephyr, we have diverse range of platforms with various architectures, compilers, target speeds, memory levels, and software features enabled. And creating a good test in such environment is challenging. It's challenging because we do a lot of assumptions while writing a test, and they may not be entirely correct for all of possible platforms. As a maintainer of one of major architectures in Zephyr, I'm serious about the state of our platforms and do care a lot about test results. So I look at tests which fail, and now I want to talk about common issues getting in the way of writing a robust test, which will be used on each and every platform we are interested in. It's based on real experience with debugging test-related issues for various Arc platforms, and it will be helpful for both who's writing new tests and who's debugging existing ones. Being an operation system, one of the basic features on Zephyr is support of multiple threads of execution, even in case of single processor hardware. And that's where Zephyr has started, on single core platforms. Later, support of multiprocessor platforms were added, and while it seems to be an essential thing, as an additional of more execution units looks like a way to make execution of multiple threads more efficient and easier, in reality it brings quite some complications. There are a lot of Zephyr kernel tests which assume interaction between different threads. And for such cases, we need to take into account multiprocessing. Otherwise, we will introduce new failures on SMP platforms. In some cases, we simply don't want our tests to be run on multiple CPUs. For such cases, Zephyr provides several options to do that. First of all, we can use the test1 CPU unit test helper if you want to run one of our test cases in single core mode. That helper occupies all CPU cores with interrupts logged, except for one core. The test case is launched. The alternate way is to set a number of cores to 1 with config mp num CPUs option. In that case, we configure fake SMP system with only one CPU core. So all of our test cases will be run on same core. But if we decided to do testing in multi-core environment, there are several common advices for that. When we are waiting for some event or task to be finished, we should use synchronization primitives instead of relying on sleeping for some time with, for example, k-sleep. Otherwise, we either need to wait for super long time, or waiting time will be insufficient for some platform. Another thing, we should prefer synchronization primitives or atomic operations to regular global variables when we are sharing some data or states between threads. Otherwise, reordering on architectures with weak memory order may break our test. There are a lot of places in tests where timeouts are used. We can roughly estimate it with such simple and regex, which is not possible to understand from first time. These are timeouts with some exact duration, which is not 0 or infinite. And if we check fixes to a test, we can find what there are a lot of fixes and related to timeouts. Timeouts in Zephyr can be specified in multiple units. Seconds-based units like milliseconds, ticks, cycles. And timeout which looks correct in one unit may be incorrect in another unit for some platform. For example, the timeout value specified in milliseconds can be less than 1 tick for platform with low tick rate. So these different timeouts are actually same for scalar. And timeout specified in ticks can be too low in terms of processor cycles for some low frequency CPU. So processor may not have enough time to do expected calculations on that platform. What can we do here? Clearly there can be any ultimate advice about it. It would be useful to think why do we select any timeout value in our test? Like, do we need waiting for some exact time? Or do we just wait to cause reschedule? If you use multiple timeout values, do we expect them to be distinguished by a scheduler? And again, if you are waiting for some event or task to be finished, please use synchronization primitives instead of relying on sleeping for some time. Tests may contain undefined behavior. Well, obvious advice about undefined behavior is to be careful and avoid it. Even if it may be not so easy with things like strict aliasing. However, some tests are using undefined behavior intentionally. For example, the error hook test do division by zero to check what hardware exception is triggered, and we can catch it. But as it's still undefined behavior, the compiler may do some strange things here, and it actually does. We bump into a situation where GCC removes the actual division here. What is possible solution? We can disable compiler optimizations, but we don't want to disable them everywhere in the whole project. We don't want to mask potential issues in Zephyr itself. So there is a specific attribute, no optimizations, which can be used to disable compiler optimizations in the exact function, where we do something strange. But even if we don't have any undefined behavior, we still can bump into compiler optimization, which breaks our test. Let's check this function, for example. It's one of the memmalloc test case, which does basic check on malloc function. What can go wrong here? Well, we bumped into this issue what some compiler removes these malloc and free calls, as it decides what result isn't really used anywhere. Compiler can do a lot of such tricks. It recognizes standard C functions and optimizes access to them. It can be either some implementation inlining or complete removal. Compiler can do calculations in compile time, and it can optimize access to variables. Generally, it's so good, and it's really helped to make code faster and smaller in size. But it also may break our test. So, how we can fix that? Yet again, we can disable compiler optimizations for our function with no optimization attribute, and we can disable access optimization for variables with volatile attribute. Okay, we've talked about some issues. Some of them may look trivial for you, but it's real issues I've bumped into multiple tests. Of course, it's only a small part of variability. Zephyr build may have virtual memory, user space, various C libraries implementations with its own specifics. So a lot of things we may need to think about in our test. Well, we can even build Zephyr without multithreading at all. It's good to rely on upstream CI when you contribute your new fancy test. The problem, though, most of the tests are run on QEMU and built with GNU compiler. So other platforms' behavior might be really different. So I hope what this talk will help you to make a robust test and strengthen Zephyr test suite. Thanks for attending the talk. Don't hesitate to ask if you have any questions. And if you need to contact with me, there are other options. Thanks.